A very good afternoon to one and all present here. On behalf of Nagindas Khanwala College, I, Dr. Amrita Agarwal, welcome Dr. Sardar Patil sir for the workshop and our dear students for the same. Today is the fourth day of the workshop on dissertation and Dr. Sardar Patil sir is going to give a very acknowledged talk on use of geospatial technology as a tool for geographical research. But before we begin with the formal deliberation, I would like to take few minutes to introduce the eminent speaker for the day. Dr. Sardar Anand Patil sir is presently working as a vice principal at ASP College Debruk and is a well-known geographer. He completed his graduation in the year 2003 from Shri Parao Chogle College, Kotoli, and has completed his MA from Shivaji College, Satara, which is affiliated to the Shivaji University, Kolhapur in the year 2005 and qualified the UGC NET examination in the year 2008 and SET in the year 2017. Sir has been awarded PhD degree in flood disaster management by the Shivaji University, Kolhapur in the year 2010. Sir has also completed a PG certificate course in geoinformatics from IGNOU, New Delhi. Sir is a PhD MPhil supervisor of the University of Mumbai since 2017. At present, Sir is eminently guiding 5 scholars for the PhD degree under his guidance in geography. He has participated in 8 weeks NNRMS sponsored certificate course on application of remote sensing and GIS in urban and regional planning at IIRS Dehradun in 2015. Similarly, Sir has also attended 8 training programs in the area of geospatial technology organized by various reputed institutions and universities throughout India. A very prestigious award has been achieved by Sir in the year 2015 by the Maharashtra Bhugol Shastra Parishad Pune, which is for the Young Best Teacher Award. Sir has organized more than 10 conferences, seminars, workshops, etc. He is a member of various academic organizations such as the Deccan Geographical Society of India, Maharashtra Bhugol Shastra Parishad Pune, Hydrological Data User Group, Shivaji Vidyapit Bhugol Shikshak Sangh, and many more. Sir has completed 4 minor research projects funded by the UGC and the University of Mumbai. He has published 3 books at the international level and has published a total of 23 research papers in various research journals. He has delivered invited talks, chaired the sessions in 28 conferences. He edited 7 proceedings, souvenirs, and is a member of the editorial board of 3 journals. Sir has presented his work in more than 47 conferences in different corners of India, and his research interests include rural planning, environmental geography, hazard studies, solid waste management, and urban geography. Sir has provided consultancy for the creation of geodatabase with a view to set up good governance to village Panitre in district Kolhapur. The regional joint director, Government of Maharashtra Higher Education Konkan region Panvel, has appointed Dr. Patil sir as the NAC coordinator for the Ratnagiri district under the leadership of Dr. Sanjay Jagtap since January 14, 2020. Sir has been in research since a long period of time and has been inspiring all the geographers not only in Maharashtra but across India. Sir, I would really appreciate all the work that you have done so far, and you are a true inspiration for all the present and upcoming geographers. And therefore, without wasting any more time, all of us are equally keen to listen to your lecture. Over to you, sir.
Thank you very much for a kind introduction. I hope I'm very much clear and visible.
Yes, sir, you're audible
Yeah,
and your screen is also visible.
thank you. Before going to address the topic, it is my prime duty to acknowledge the initiation of Nagindas Khandwala College, Malad, for organizing such a wonderful workshop on dissertations, its writing. In this workshop, the students from Nagindas Khandwala College and some of the students from ASP College Devruk has been participating, and I'm sure this workshop will definitely provide a new direction for conducting the research and submitting the research project in the fourth semester. First of all, I extend my sincere thanks to our philosopher guide Dr. Moushmi Datta for giving me an opportunity to deliver an address here. Also, it is my duty to extend my sincere thanks to Suresh Setkar sir, Prakash Dongre sir, and Dr. Amrit Agarwal and the entire geography team from Nagindas Khandwala College, Malad. Dear friends, now I am going to talk around 1 hour or little bit more or less, and I am going to address the topic that how we can utilize geospatial technology in geographical research. There is a misconception some of the geographers are considering geospatial technology as a research methodology. But geospatial technology is not a research methodology. It is a tool that can be used as a part of research methodology to analyze the data, to process the data, and to conclude with proper decision making. In this half an hour, we are going to address about fundamentals of geospatial technology, then need of understanding geographical basis in application of geospatial technology, analysis techniques in GIS, areas of geographical research, applications of geospatial technology in general, and one focused example of forest cover change analysis, that how we can utilize geospatial technology for the analysis of forest cover change detection. This is the outline of our talk on use of geospatial technology as a tool for geographical research. Thank you. Then, when we consider about Bloom's taxonomy and this session, you will be able to remember the concepts like remote sensing, GIS, global navigation, satellite systems, and geospatial technology. You will be able to understand conceptual background of geospatial technology, applications of geospatial technology, and need of geographical basis in geospatial technology applications. You will be able to apply geospatial technology to solve the real life problems, that the problems which are you are going to select as a part of dissertation in the next semester. For that, it will be very much useful that you can apply the geospatial technology. You will be able to analyze the correlation between geographical understanding and geospatial technology, because without geographical understanding you won't be able to apply the geospatial technology. So it is the necessary to understand, or it is the need of the time to understand the correlation between the geographical background and the applications of geospatial technology. You will be able to evaluate the applications of geospatial technology in geographical research, and at last I hope that you will create your own model of land use land cover analysis using this lecture. And if you are able to create your own land use and land cover model, at that time I can say that this lecture is really helpful to you. Otherwise I wasted my time and there was not use of this lecture. Okay. What is geospatial technology? There are various words nowadays are being used for the geospatial technology. Uh, Someone is calling as geoinformatics, someone is calling the spatial technology, or we can say it is a geospatial technology. When we talk about geoinformatics is the synergy of several disciplines where as geospatial technology is a part of geoinformatics, most probably remote sensing, GIS, global navigation satellite system is included in geospatial technology. If you look at this picture, you can see here that remote sensing, then geographical information system, then global navigation system, satellite system, and moreover photogrammetry and computer science may be included in geospatial technology, whereas when we are talk about geoinformatics, it is a synergy of several disciplines. It includes cartography, it includes remote sensing, it includes GIS, it includes global navigation satellite system, photogrammetry, computer science, geology, geodesy, geography, etc. What are the core areas a branch of knowledge that are included, or we can say the branches of knowledge which we are analyzing with the help of locational information that may be a part of geoinformatics, and we are talking about geospatial technology. The applications of geospatial technology are mainly oriented in real world management of problems pertaining to natural and man-made environments. Geospatial technology has become an important tool across a wide range of disciplines for research and academia. For example, nowadays in the subjects like chemistry, botany, physics, then geography, geology, uh, geospatial technology is being utilized as a tool for research and academia. And very recently, you can say that now geoinformatics is a separate branch of knowledge that evolved and it has its own applications. But now we are going to address the topic in context with how we can utilize the geospatial technology related to geographical research. So, geospatial technology is defined differently by different authors or scholars with different approach. But we can say that geospatial technology is a science and technology that deals with the acquisition, storage, processing, presentation, and dissemination of geospatial information. When we talk about geospatial technology, the major fields mostly include the GIS, Geographical Information System, and in GIS we can say manual cartography, information explosion, computer, internet. For internet we can say that is web GIS is a tool for data analysis. When we talk about remote sensing is a tool of data collection. Remote sensing is a tool of data collection. GIS is a tool of data analysis. And when we talk about GPS or global navigation satellite system, it is a tool of data validation or verification of the data. In remote sensing also we can see here that is aerial remote sensing, satellite remote sensing, thermal remote sensing, radar remote sensing. N number of types are there concerning remote sensing. When we talk about GPS, it is ground-based survey, there satellite survey, mobile surveillance and tracking, etc. These are the components of GPS, or we can say global navigation satellite system. What is remote sensing? Remote sensing is an art and science of acquiring information about an object without coming into physical contact with it. And when we talk about remote sensors, we have also remote sensor, our eyes, our ears, and our nose are remote sensors. When we talk about satellite remote sensing, there are various types of remote sensing are there. That is, one is imaging and non-imaging. For example, we are listening. This is non-imaging type of remote sensing. Similarly, it happens in satellite remote sensing. Imaging, when we observe anything, at that time we can draw a picture, that is imaging remote sensing. Same is happening concerning the satellite remote sensing. Also based on the source of energy, the remote sensing can be classified as active and passive remote sensing. Beyond this, there are various types of remote sensing are there. We are not going to address the types of remote sensing in detail. Just I am giving an insight to you, that is what is remote sensing and what are the fundamental types of remote sensing. When we talk about GIS, GIS is nothing but a computer assisted system specially designed for the mapping, measuring, monitoring and manipulation of geographical data. What is geographical data? The data which has the locational information that we can be included in geographical data, or we can say it as a spatial data. Suppose, for example, now I am delivering a lecture. I sit in a room. The room has itself has locational information. It is a part and parcel of spatial information or geographical information. Whereas the there is another type of data can be integrated into GIS, that is called non-spatial or attribute data. In this image you can observe here that GIS has the capability to manage multiple layers in a single mm, at a single time by the tech of employing the techniques like overlay analysis, bufferlay analysis, proximity analysis, network analysis. So many analysis techniques are there. We are going to address that techniques in the forthcoming part of this lecture. But you can conclude that GIS has the capability that it can integrate all types of data. What is GNSS? Global Navigation Satellite System. Global Navigation Satellite System is a general term describing any satellite constellation that provides positional navigation and timing services on global or regional basis. For example, most commonly used is GPS services. When we talk about regional services, India has Gagan, that is IRNSS, Indian Regional Navigation Satellite System is there. It is a part of GNSS because we are using GPS as a input, and we are strengthening or enhancing our locational information by installing more satellites in Indian subcontinent region. While GPS is the most prevalent global navigation satellite system, and other nations are building or have built their own systems to provide complementary independent positioning, navigation, and timing capability. But even though when you talk about GPS, if in your mobile you are using Galileo system, you are using compass, you are using GLONASS, but even though we are talking that we are using GPS, it is similar like that when you go to rural areas, and the persons living in rural areas, they are asking for Nirma, and even though they are going to purchase wheel powder, they are calling it as a wheel nirma. Similarly, it is related to GPS, that we, instead of global navigation satellite system, we are talking it is a GPS for Galileo also, for GLONASS also. Okay, why we need to understand the geographical basis in application of geospatial technology? Because geospatial technology is a tool for data collection, tool for data analysis, and tool for data validation. Before applying the geospatial technology in geographical research, first of all we need to understand what is geography and what are the basis of geography that we are going to apply. With a proper understanding of these bases or baselines, we are going to apply the geospatial technology to solve the real-time problems related to geography. There are various definitions have been given by various authors related to geography. Initially, it was called description of the earth is called geography, but I can say the systematic analysis of physical, social, cultural, economic components with spatio-temporal perspective with the view to develop laws, theories, and models is called geography. Nowadays, geography, the nature of geography has been changing. Now it became more scientific, and geography is also focusing on the development of laws, theories, and models. And this should be also the motive of your research. When you are going to select a topic and you are researching that topic, you should ask a question. Either you are going to add some new facts to the field of knowledge, either your research is really helpful to solve the real-time problems of society or nation, either your research will be beneficial for the society. If the answers are yes, at that time you are researching at the proper way. Otherwise, it will be just only copy and paste, or just only applying the methods that are being applied by the other persons, and you are applying that techniques to a different region, nothing else. Okay. Generally, geospatial technology enables us to acquire data that is reference to the Earth and use it for analysis, modeling, simulation, and visualization, etc. When we going to apply geospatial technology in geographical research, at that time we should understand the importance of that topic and priority of the resources. By proper understanding the importance or significance and priority of the resources, we will be able to apply the geospatial technology in a systematic way for fruitful end of the research. Generally, in application of geospatial technology, what is happening? It is GIGO, that is garbage in, garbage out. Sometimes wrong information is being provided by some of the researchers or those the persons who are going to enter the data, and that garbage in is responsible for the garbage out. For example, if the person doesn't know what is topography and he is going to apply the geospatial technology for topographic analysis or mobile tower network analysis without understanding the topography, its shadow, and the direction from where or the location from where we are going to install a mobile tower, it will be only garbage. Or sometimes it happens that persons are generating contours but they don't know what does mean by contour. What is the correlation between contour and map scale? What is the VI, that is vertical interval? What is HE? What is horizontal equivalence? And without understanding these fundamentals, they are generating the contours and only providing the garbage in, and that is responsible for the garbage output. So before going to apply geospatial technology in geographical research, you should have proper knowledge of that field where you are going to apply the geospatial technology. For example, some of the students from you are going to address the problems of urbanization. They are, suppose they are unknown about the urban systems, what are the problems of urbanization, what is the correlation between physical, social, cultural, economic components, how the policy, government policy is affecting on urbanization and problems of urbanization, and they are going to apply the only technology that will be garbage, and the applications or the results acquired through the application of geospatial technology may not be useful or fruitful for the development of that region. So keep in mind, before going to apply the geospatial technology, you need to understand the geographical basis of the topic that you are going to analyze. When we talk about geospatial analysis, there are various geospatial analysis techniques are available in GIS. Either it is paid softwares like ArcGIS or the free softwares like QGIS. But these are the various analysis techniques are available through these GIS softwares. First is overlay analysis. In overlay analysis, one technique is there, point in polygon overlay. What is the procedure here? Here input layer will be a point layer and polygon layer is a overlay layer. For example, suppose I have these settlements and I have another map of that region, and we are going to overlay. At that time, input layer will be the settlement layer and output layer will be the shape file of that is polygon shape file of that region. Then when we will overlay point by polygon, at that time, as shown in these figures, the attributes will be changed. This is the overlay, that is point in polygon overlay. Second one, line in polygon overlay. Input is a line layer in this case, and we are going to overlay by polygon layer. At that time, again attributes will be changed, that A1 and B1. One is the line layer, then AB, these are the polygons layers. We are going to overlay by polygon layers. At that time, the attributes of the original line layer will be changed, and hence the output will be different. That is line in polygon overlay. These are the two important overlay techniques. In spite, you can overlay the non-spatial information also. For example, suppose you are going to analyze the topic of population. At that time, you can overlay the elevation information by density of the population or other parameters that you have selected to address that topic. That type of overlay analysis is necessary, and then you will be fine to you will be able to address any model, or you will be able to find the last region models related to population geography. This is one of the examples. Second one is buffer analysis. What is buffer? Generally, buffer creates buffer polygons around specified features in a layer. Either it is point layer, line layer, or polygon layer. And buffer creates new polygon layer in the over the original shape file. Then input layer can be point segment or polygon layer. In a segment or polygon layer, one can create inside or outside or both sides buffers. Suppose you are going to address the topic how the newly developed highways are affecting on land use, and at that time you can create the buffer from line segment, and this buffer will be towards two sides, and in this way we can conclude that generally from the highways or expressways, the land use till the distance of 1 kilometer is drastically changed. For the such type of analysis, buffer analysis is necessary. Then using a single buffer distance, it creates buffer zones of the same width around the selected features. Generally for uh, the topics like flood disaster management, elevation based buffers are generally created, because buffers are created either one side. Suppose for example this is a line segment, we are going to create a buffer towards two sides, means it will be towards two sides. Then it may be created towards only one side, or it may be created considering the elevation information, and such type of buffers are generally used in the uh, research topics like flood disaster management, or where elevation information will be the input or as a base of analysis of the data. These are some of the illustrations or examples of buffer analysis. Here you can say that is line buffer, then second one is point buffer, then internal buffer and external buffer. Internal buffer means this buffer has been created towards internal side only, and this is the external buffer that the system was provided only specific distance towards outside. Such when such type of buffer analysis is necessary. Suppose there is a local government, they have purchased the land for the installation or for the starting the solid waste management project. At that time, there are certain rules and regulations provided by the central government regarding the management of solid waste and starting the processing project for the waste processing project. At that time, it is necessary that we should have a buffer of 500 meter, 200 meter based on the location of that site, and what are other parameters are there, how much toxic gases will come out from that project. Based on that, we need to create a buffer, and so at that time external buffer is required. Next, in geospatial analysis, proximity analysis is another method that is generally being used for the analysis of geographical data. But what happens, some geographers taking buffer analysis and proximity analysis synonymously. But these are not synonymous. These are different terminologies. Buffer is different and proximity analysis is different. I'm not going to say detail light on this technique. You just Google it, considering your research topic, then you will be able to find out which technique is most suitable for you. And after selecting your topic, if you thought that, sir, I need your guidance in related to this topic, you just convey to me. I will be there to help you. Another one is network analysis. For example, you are using Google Maps. What is this? This is network analysis. Google Maps are based on the principle of network analysis. Either one way is there, either two way is there, or what is the road condition, etc. So network analysis is there generally to with the view to analyze the connectivity and accessibility. The network analysis is used. And suppose you are going to address the topic related to transportation, at that time you can use network analysis, and for the network analysis QGIS is the most suitable GIS software, and it is open source also. Next, geostatistical analysis. If you go to GIS software, either it is ArcGIS or any other, their geostatistical analysis is there. This is the ability of GIS, because generally GIS is like similar to database management software, but what are the merits beyond other database management softwares is there, that it has the capability that it can analyze spatial information, non-spatial information. Also, it has the capability that spatial information can be analyzed with application of statistical techniques. That is, geostatistical analysis is there, and you can apply geostatistical analysis techniques while doing research in geography. Suitability analysis is one of the important technique that is being used as an analysis technique in geographical research or for the site selection. But what I consider that suitability analysis is not a separate technique. It is a part and parcel of overlay analysis, buffer analysis, network analysis, proximity analysis. So we can't say that this is a separate technique or separate type of geospatial analysis. Generally, there are two branches of geography. One is regional geography and another one is systematic geography. These are the areas of research. If I started to talk on areas of geographical research, it may require more than 30 minutes if I am going to address each and every aspect systematically. But I thought that I should include entire geographical topics two ways. One way is the regional or systematic. Most probably in geography, research is regional research. Why? Because persons are either selecting Maharashtra or Ratnagiri district or Mumbai region or Raigad district, or it may be a taluka, it may be a village, and we are going to analyze the data with spatial and temporal perspective. So regional and systematic, these are the two approaches. Most probably in climatic research, systematic approach is there. In geomorphological research, systematic approach is there. But where human aspect is there, at that time, regional approach is there. And the results are vary from region to region. Another one, and this is the most important, that either you are going to select your topic from human geography or physical geography. And I can say that there is no limit for the selection of topic in geography, or we can say this is the area of geographical research. Suppose, for example, you are going to analyze the education, and if you are talking about Raigad district, that how there is variation from Tahsil to Tahsil, that will be your spatial analysis, and how the educational systems have been changing since 1991 at the decadal interval, that will be your temporal analysis. Also, you will be able to analyze site, or you can able to apply the site suitability techniques, that you will analyze proximity analysis, you will be apply the overlay analysis technique, buffer analysis techniques, and you will be find that, or you may be able to find that these are the some of the educational institutions, these are not necessary at all, and in this region there is need of new educational institution considering the other parameters like population and industrial development and other parameters that might be set by you. So in case of geography, each and every topic can be addressed. For this semester, actually, I have given one topic related to political geography for PG students. That is how gender is affecting on active participation in politics. This is also part and parcel of geographical research. So for geographical research, there is no limit. I can say sky is the limit. Each and every thought that is being that is coming in your mind, it may be a part of geographical research. Only you need to think with spatial and temporal context. And if you are thinking with spatial and temporal context, at that time it will be part and parcel of geographical research. Now I will give some insight related to what are the applications of geospatial technology. In very short span of time, I will complete this slide. So we can spend our maximum time on forest cover change analysis. Resource management is one of the applications of geospatial technology. What are the resources are there? Water resources are there, soil resources are there, some natural resources are there, forest resources are there, and for the proper management of these resources with the view of sustainable development, we can use geospatial technology. This is one of the application of geospatial technology. Next, land use planning, or you can say land use land cover analysis. Suppose we have selected a region, and in that region government has planned that here some new industries will come. At that time, there is need of proper land use and land cover analysis, or providing a proper land use plan to concerned authority. So in this case, we can use geospatial technology as a tool of research. In agriculture, n number of applications are there. Suppose, for example, in this now we are in Rabi season, and if we are talk about Punjab, what will be the estimated production of wheat by the end of the Rabi season? Then what is the level of growth of wheat? Then what are, if there is any disease or else, either the growth is uh, as per standard parameters or not. Such type of analysis is possible using geospatial technology. I'm talking in general because it is not possible to talk in detail about each and every application of geospatial technology. Or you can consider that these applications are areas of geographical research, and you can select any one topic from the given, and accordingly you start working on your topic. Next one is forestry. That what are the types of forestry? Then forest cover change analysis. Either forest cover is increasing or decreasing. Then if there are some important plants are there, then what is the position? Then I mean, what is the condition of the that forest, etc. A number of questions can be answered using geospatial technology. Then water resources management, either it is groundwater or surface water. Suppose, for example, if you are working on groundwater of a X region, and in that case you have surveyed these various wells you have surveyed. While surveying, what you will do, you will get the detailed information, its latitudinal and longitudinal information, then level of water with changing time each and every month, what is the level of water, then its uh, properties, either it is physical properties, chemical properties, and biological properties. And in this way, in GIS you can use the inverse contouring technique, and through inverse contouring technique you can interpolate, or I can say that you will define or determine the level of groundwater, and how this groundwater level is changing from season to season, from month to month, and from year to year. So such type of water resource management, for the analysis of water resource management, geospatial technology is one of the significant tools. Then rural and urban planning. I haven't copied here the slides from another project, that is good governance. But I am of the opinion that for the rural and urban planning, geospatial technology is most suitable tool. We can address and analyze physical, social, cultural, economic, political information, and we can develop our own models of development, either it is rural development or urban development. Generally, I will say the applications of geospatial technology are endless. It will end only the end of thinking. If I am thinking that yes, I am going to correlate, these are the various parameters, and this will be output, at that time it is possible. Suppose, for example, I would like to share, and I usually share this experience. In 2013, I was in Nainital University, and there one sociologist was there along with us, and he asked, "Sir, you said geospatial technology, that is remote sensing, GIS, GPS, is most useful. How we can use this technology to stop the suicides of the farmers in Maharashtra?" You may laugh that is it possible to stop the suicides of farmers using geospatial technology? Suppose I have this satellite, and now this satellite is watching that some one farmer is going to commit the suicide. It is not possible at all to stop his suicide. But we have, if we have expertise at that time, what we will do precautionary measures using geospatial technology. We will find out the intensity of droughtness, because drought is one of the important causes of suicides of farmers. And if the droughtness index is at the higher level, at that time there is a possibility that farmers may commit the suicide in this year. So we will organize awareness programs for the farmers, and in this way we can control or we can minimize the suicides of the farmers. So keep in mind, even though I am going to share very few applications of geospatial technology, each and every question can be addressed using geospatial technology. You come with question, we will find the answer, that how we are going to correlate. This is the matter of expertise. Then for environmental management also, geospatial technology is widely used. Then for risk management, suppose there is a industry and there is a possibility that fire has started here. There are some simulations that if the wind is flowing from west to east, at that time what will be the impact of this fire towards eastern side, or to what extent it will be affect on the population, settlement and other industries. That is risk management. And for the analysis of risk management, geospatial technology can be utilized. Then business marketing, for example, we have one course that is environmental studies. What I did after becoming our college autonomous, we made changes in the syllabus and we incorporated e-marketing using geospatial technology. That how we are going to apply the geospatial technology for e-marketing or e-business. There is one application of Google, that is Google Business or My Business application is there, and as a with the view to demonstrate to the students, because it was not possible without giving the practical example. So I registered one firm, that is Bhagyanand Land Measurement Services. Bhagyanand Land Measurement Services. And very few days before, one person come to me, sir, I saw your advertisement on Google, and this is our land parcel. Kindly provide your consultancy. I am ready to pay you what you want. And this is possible only because of geospatial technology, and you can do it. If you have any skill, and considering that skill, if you are interested to provide your consultancy for the society, you can publicize using geospatial technology. In real estate nowadays, geospatial technology is widely used. For example, if you go visit any site of real estate builders, they have such type of plots, and each and every plot, if you go to web, that is web GIS, and click there, you will see that either the plot is available or sell, what is the dimension, to at what distance school is there from that plot, either water facility is there, public transport facility is there, and number of questions that are coming in your mind that may be addressed uh, through portals in real estate business. For facility mapping also, geospatial technology is widely used. Either it the facility provided by government agencies, then non-government agencies, any schools, colleges, etc. We very recently we completed the mapping of our institution through the Department of Geography. Next, transportation management. I already talk about it, because in transportation management, network analysis is the best suitable technique, and through network analysis technique, you will be able to find out the connectivity, accessibility of the region, and not only that, you will be able to find out the substitute routes. Regarding transportation management, suppose I am interested to build a road between these two locations. At that time, we will be able to find out how much land needs to be filled and how much lands need to be cut using the GIS softwares like Global Mapper. In that software, this facility is available. Then for telecommunication, suppose I interested to install a telephone tower here, then to what extent it will be beneficial for the society considering the topography and which location will be best suitable to provide the services to the maximum person. Such type of analysis is possible in or using geospatial technology. Then for mining, government agencies are also using geospatial technology. Very recently, Peak Pani application has been developed by government of Maharashtra, and through that application, government is trying to acquire the information related to agriculture from the farmers using the locational information. Then in defense services, geospatial technology is widely used throughout the world. And if you talk about the GPS, itself started from the defense application, and later on it was made available for the public. And even in case of the border security, India is also using the geospatial technology. Some developmental satellites are there that are always watching the border areas and the movements by various enemy countries. Then for emergency operations also geospatial technology is used. I'm just skipping the matter because my main motive is to address the topic of forest cover change, how we can use the geospatial technology with practical example related to forest cover change. Then for crime management also, that you can determine the hotspot of crimes or where any specific activity is happening frequently, and at that time you can develop your own model that if we are going to use this substitute, at that time we can minimize the crime rate in that specific region. In case of archaeology also, nowadays geospatial technology, that is remote sensing, some GPR is there, that is ground penetrating radar is there. That ground penetrating radar technology is used in case of archaeology. Good governance is one of the example, ideal example I can say, but in case of India till today it is not initiated, but you can take project related to any village or any ward from your locality, and you can apply the geospatial technology as a tool for good governance. Education, in case of applications of geospatial technology related to education, we have already talked about the same. Only thing is that you need to address each and every topic with spatial and temporal perspective. Always keep in mind what is geography. Geography is a science that deals with the systematic study of physical, social, cultural, economic, political, etc. components with spatial and temporal perspective with the view to develop laws, theories, and models. Your main motive when you are going to research a topic, your main motive should be to develop laws, theories, and models. For example, Ravenstein has invented some of the laws related to migration. For example, one law is there. Most of the migrations are for the shorter distance. This is one of the law. How he able to find out? He just analyzed the data, and after analyzing the data, he observed that most of the migrations are for shorter distance, and when the distance increases, the rate of migration is also decreases. The migrations of women are marriage related because most of the women migrations are marriage related. We don't have system that after getting married that male candidate is moving towards female house of the female candidate. Such type of systems are not available in our country. Some exceptions are there. We can say घर जावई वगैरह वगैरह. So these are some of the examples of geospatial application of geospatial technology. I hope you might have cleared about what is geospatial technology, what is geospatial analysis, what is geography, and what are the applications of geospatial technology. Now we are going to address this is one of the research topic that completed by me, and it was completed when I was in initial stage of learning. It means when I started learning, at that time I was doing experiments, and after doing experiments I completed this project. It was application of geospatial technology for forest cover change analysis, a case study of Sangameshwar Taluka. I am not going to read what is the appraisal of the problem, what is the review of literature. While completing this project, one limitation was there, that is non-availability of village boundary map, because this project was completed in the year 2013, and at that time I was not aware about the sources for village boundaries, sources for downloading the village boundaries in shape file format. But now you can, if you visit to WARIS website, that is Water Resource Information System, from that website you are able to download the village boundary maps also for entire country, for entire Maharashtra, or for any region uh, in which you are very much interested to pursue your research work. Where is Sangameshwar Taluka is located? If you talk about Ratnagiri district, you can see here that in Ratnagiri district, one Taluka is there, Sangameshwar. Its latitudinal information is 16 degree 54 minutes, 15.9303 north to 17 degree 19 minutes 55 second north. Longitudinal information is 73 degree 24 minutes, etc. The general most important fact is that the elevation of the Tahsil ranges between 1 meter and 1038 meter. That is, lowest elevation of the Tahsil is 1 meter from the mean sea level, and the highest elevation of the Tahsil is 1038 meter from the mean sea level. The main objective of the present research work was to analyze the forest cover change by using geospatial technology and to suggest a comprehensive plan for sustainable management of forest resources. This is you need to understand, because suppose you thought that I need to work on forest cover change. At that time, you should be aware about the methodology. Regarding methods of data collection, because in geography we always talk about methods of data collection and methods of data analysis, and this research project or paper was based on primary as well as secondary data. In considering the primary data was collected through field investigations, observation method, as well as informal personal communications with the view to support satellite data. And the secondary data was collected from Landsat TM 1989 for the year 1989, Landsat ETM Plus 1999, List 3 for the year 2009. Being an expert in the field of one of the experts in the field of geospatial technology, this is not a proper way of selecting satellites. Please keep in mind, that's why I already cleared that when I completed this topic in the year 2013, at that time I was in learning stage. Why it is incorrect? Because all the three data sets should be in single from the single satellite or sensor. At that time, it may provide very accurate information. Otherwise, there is a possibility that some fuzzy information is acquired after the analyzing the data. So, if you are going to apply geospatial technology for forest cover change analysis, please keep in mind this information, I mean satellite data, has been downloaded from GLCF. It is free of cost available. You can register yourself to Global Land Cover Facility. And from Bhuvan website, Bhuvan is Indian website. And after registering to the Bhuvan website, you can download the remote sensing data from Bhuvan websites also. Also, I downloaded the shape file from DevaGIS. If you uh, Google it, you will be able to find out DevaGIS, and from DevaGIS you can download the shape files for entire world for political boundaries, road networks, water bodies, etc. Some may require to add at your end, or there may be some of the shape files that you downloaded from DevaGIS, and if you are going to address the topic like population geography, social geography, cultural geography, economic geography, at that time these data sets may be much more helpful to you. Also, Garmin's Oregon 550 GPS was used for the ground truthing and validation or verification of the data. Considering the methods of data analysis, these are based on two GIS software. One is ADAS Imagine and second one was ArcGIS. ADAS Imagine is a image analysis software and ArcGIS is general GIS software. I tried to integrate ADAS Imagine and ArcGIS and was doing only experiments. So it will be very much interesting to you. In ADAS Imagine, layer stacking was carried out. If you download the data, satellite data from any website, you will be able to find that uh, we are downloading different layers and you need to perform layer stack for the creation of the image. Then supervised classification technique was applied, and the four parameters or four types of forests were decided, and accordingly supervised classification technique was used to find out the forest cover and the changes between the 1989, 1999 and 2009, and accordingly afterwards change detection analysis was carried out. This is related to ELDAS. Afterwards, classified image was used as input in ArcGIS. Then polygons were generated from the raster layers, that is classified image. And you will be surprised, suppose for the year 1989, there were 4,79,000 polygons were there, and these 4,79,000 polygons were related to four types of categories, that is dense forest, moderate forest, scrubs, etc. So what I did, it was not very easy to analyze or to use the layers, polygons 4,79,000 for any type of decision making or analysis. So I dissolve it. What is dissolve? The dissolve has capacity to merge the polygons, especially attribute information, considering the parameters set by you. Okay. Then Overlay analysis was carried out. For that purpose, intersect technique was used, and afterwards the data, attribute data acquired after intersecting and overlay analysis was exported, and final output maps were prepared. These are the some of the results and discussion. See, these are the four types of forest that I were used for the forest cover change analysis, that is dense forest, moderate forest, scrubs, sparse vegetations and agricultural land, and then non-forest area. These are the four types of land use, you can say, that were decided by me. And for the year 1989, you can see here that is there were 3.47% area was under dense forest, 11.62% area was under scrubs, 57.10% area was under moderate forest, and non-forest area was 27.81. It changed to 23.80 in the year 1999 and 22.74 in the year 2009. And also there is interchanges there. We will look in the next slides. See, this is the area under various forest types. You can see that the attribute data again exported to Excel, and in Excel this graph was prepared. The dense forest overall, the dense forest area is at the lower side for all the years, but you can see here that in the year 1999 it seems to be increased to some extent. Then consider when you talk about moderate forest, in the year 1989 it was highest, but in 1999 and 2009 it decreased. Scrubs and spar forest, the area increased with the march of time, and also non-forest area is also decreased with the march of time. These are the results acquired through the analysis of the images. This is forest cover area map. You can see here dense forest area, moderate, then non-forest area, and scrubs. These were the four classes decided at that time, and these images you can see what was the situation in the year 1989, what was situation in 1999, and what was situation in the year 2009. Just after observing the images, you can easily identify that the forest cover is changing with the march of time. Okay. If we talk about decadal change, in initial first decade, that is 89-99, the dense forest area was increased. If you talk about in percentage, it was 83.97% increase in the area under dense forest, and in the next decade it decreased to 39.01%. Similarly, scrubs in first decade it seems to be increased by 346.33%, and in the second decade, that is 99-2009, it increased only by 4%. Then non-forest area in the first decade it decreased by minus 14.40%, and in the next decade it decreased by minus 4.44%. Okay, this is the periodical change. Again, I tried to depict the information using the graph, and here you can see that where there is a negative change, it is towards the downward side has been shown here. Okay, now this is the pattern of forest cover change between 1989 to 1999. See here, on rows as well as columns same names are given, and for that purpose Initially I've used the dissolve technique, and later on I use the intersect technique, and after this is a result of intersect or intersection, that how much area between the period of 1989 to 1999 shifted from dense to dense. It means it remains stable, and it is 62.71%. Then in this, from dense forest to moderate forest, it is 23.79%. From dense forest to scrubs and agricultural lands, etc., it is 11.79%, and to non-forest area, it is 43.84%. Okay. Similarly, changes of moderate forest to dense forest, moderate to moderate, moderate to scrub, and moderate to non-forest. Similarly, scrubs to dense, scrubs to moderate, scrubs to scrubs, scrubs to non-forest, and non-forest to dense, non-forest to moderate, non-forest to scrubs, and non-forest to non-forest. And here you will be surprised that maximum changes are there in scrubs and vegetations. Same pattern have been depicted here using the graphical methods. In this map, you will be able to see that the higher elevation portion of the district is remain unchanged. Here, see, this is the example. The higher elevation portion of the Tehsil was not changed in the first decade, that is 1989 to 99. But when we talk about internal changes, that is, I already talked about dense to dense, dense to moderate. This is the pattern of change during this first decade, that is 1989 to 1999. This is the tabular format information for the next decade, that is for the year 1999 and 2009. Now I am not going to focus detailed light on that, because my motive is that you should understand the techniques that I have applied for the completion of this project, and if you are able to use such type of techniques, that will be more better. Same change have been depicted here using the graphical technique. Here, see, during the first decade of 1989-99, the higher elevation portion was unchanged, but it is not the in case of 1999 and 2009. In this decade, you can observe here, entire forest cover has been changed. Only few pockets are there where we can see unchanged land use. Otherwise, most of the land use or most of the forest cover has been changed. Either it is shifted from one farm to another farm, or deforestation is happened here. And again, I tried to explain here what are the internal changes happen in case of in the decade, internal changes regarding forest cover in the decade of 1999 and 2009. Generally, I don't rely always on remote sensing data. So I did the fieldwork of entire Tehsil by visiting almost 100% Tehsil wherever possible. And I observed that at most of the pockets, there was pocket uh, deforestation was there, and this is also sometimes we are not able to depict or predict or get the information from satellite, because it depends upon what is the resolution of the data. Because suppose you have selected data of 30 meter, and if any land parcel is there on the ground, that is 50 meter by 50 meter pocket deforestation uh, has been happened. At that time, you may not be able to get the information regarding that deforestation through satellite data. Thank you for your patience. And at last, once again, I extend my sincere thanks to the entire team of Nagindas Khandwala College. Thank you. If you have any queries, any questions, you please feel free to ask.